Welcome to Study Loop.
We can first say that here we're going to let plus x be horizontal to the right, essentially, and then plus y be upward. So we can then say that we can say delta y, which essentially would just be equal to the height. We can say that then this would be equal to vy initial t, which we know the initial y velocity would be 0, plus 1/2 gt squared. So we can say that then the time in the air would be equal to the square root of 2 times h times the gravity, whichever planet it is, regardless of Earth or planet X. And we have then that delta x, because there isn't any acceleration in the x direction, delta x is going to be equal to vx initial times t, and this would be simply equal to v initial, because they're being fired perfectly horizontally, multiplied by the square root of 2h divided by d. And so now we know that delta x equals d on Earth. However, delta x equals 2.76 d on planet X. So we can then say that essentially, because delta x multiplied by the square root of g, this is going to be equal to the initial velocity times 2 times the height. Because they're firing it at the same initial velocity on both planets, and they're firing it from the same height on both planets, this is going to be equal to a constant. So we can set up a proportion, or essentially a ratio, and we can say that then d multiplied by the square root of gravity on Earth will be equal to 2.76 d times the square root of the gravity on planet X. And so the acceleration due to gravity on planet X would be equal to the acceleration due to gravity on Earth divided by 2.76 squared. That would be divided by 2.76 squared. And so the gravity on X would be equal to 0.131 times the gravity on Earth, and this would be equal to 0.131 times 9 meters per second squared. So the gravity on planet X is going to be equal to 1.28 meters per second squared. This makes sense because if the gravity is lower, therefore we have a larger range, and so it traveling farther on planet X makes sense, and we are expecting a lower gravity than the gravity on Earth. So again, our final answer, 1.8 meters per second squared. That is the end of the solution. Thank you for watching.